Hi everyone. So today I will be doing chemistry paper 4 theory, and this May June 2023 series paper 4.1. So this paper has 16 pages. So let's begin. So question 1. Some simple equations and word equations A to J are shown. Use the equations to answer the questions that follow. Each equation may be used once, more than once, or not at all. So A neutralization reaction. So which equation is a neutralization reaction? So remember, neutralization means you want to combine an acid plus an alkali. When you combine these two together, you'll get a neutralization reaction, okay? So which of these represents acid plus alkali? It's actually B. Why? It's because acids contain H+, alkalis contains OH minus, and you'll produce, they'll react together to form water. So this is a staple example of a neutralization reaction. So the answer for A is B. For part 2, part B, a precipitation reaction. So a precipitate means an insoluble salt. Will be formed, right? So if you form an insoluble salt, you just need to see, out of all these equations, which product contains an insoluble salt. And from what I can tell, the only one that actually has an insoluble salt is A. So the answer is A. The formation of an ester. So how do you identify an ester? The esters are from an alcohol plus a carboxylic acid, right? So which is an alcohol? Ethanol is an alcohol. What is a carboxylic acid? Ethanoic acid is a carboxylic acid, and you form ethyl ethanoate. This is the ester, right? So the answer is H. Next, photosynthesis, right? So what's the equation for photosynthesis? Is CO2 plus H2O. You get oxygen and glucose, right? So which equation represents this? The only one that represents this is J, right? So this is the carbon dioxide, this is the water, this is the formula for glucose, C6H12O6 and 6O2. Therefore, answer is J. Next, fermentation, right? So, you know that fermentation produces ethanol, right? So the first step is going to look at what produces ethanol. So I see that E produces ethanol, and I see that E produces ethanol as well as G, right? So this is actually ethanol as well. So between E and G, which is correct? So fermentation is you're using glucose to turn into ethanol. So therefore E cannot be correct. So E is actually hydration. This is a hydration reaction, right? So fermentation therefore has to be G. You're taking the glucose, you're turning it into carbon dioxide and ethanol. And finally F, cracking. So what is cracking? Cracking is breaking a larger alkane or alkene into smaller alkanes or alkenes. So take a larger alkane, which is D, right? See, this is a big alkane, and you break it into smaller alkanes and alkenes. So you just need to make sure that the number of carbon in the products is the same as the number of carbon in the reactants. So you need to check for that. So therefore the answer is D. Okay, next. Question 2. The symbols of the elements in periodic 2 of the periodic table are shown. Use the symbols of the elements in period 2 to answer the questions that follow. Each symbol may be used once, more than once, or not at all. Okay. Give the symbol of the element that makes up approximately 78% of clean dry air. So this one should be pretty simple. It's nitrogen, right? It exists in N2 and it forms 78% of air. And for part 2, contains atoms with only 3 electrons in the outer shell. So they tell you that it has 3 electrons in the outer shell. So it means that this atom is in group 3, right? So you just need to look at the periodic table. And in period 2, which of these is in group 3? Boron. Boron is in group 3, right? So answer is B for boron. Part 3 contains atoms with only 9 protons, right? Having only 9 protons means that it will have a electronic configuration of 2, 7, right? Because the first shell will only fit 2 electrons. The outer shell will fit 7. So what has 7 outer shell electrons? It's a halogen. So which of these are halogens? Fluorine. So answer is F. Exists as graphite. So it should be pretty simple. Carbon. Carbon can exist as graphite or diamond as well. Okay. It's an alkaline metal. So just from hearing alkaline metal, you will know that it is a group 1. So which of these in the period 2 is a group 1 alkaline metal? Lithium. Answer is Li. Only has an oxidation number of 0. Right, so for this one, having only one oxidation number and the oxidation number is 0, which means that this is actually unreactive. So therefore, out of all these, which is the most unreactive? Neon. Done. Next. Boron has 2 isotopes. State the meaning of the term isotopes. Right. So an isotope is having different atoms of the same element with the same number of protons and different number of neutrons. So the important part is first you need to state that is different atoms of the same element. So this first part is important. They need to be different atoms but part of the same element. The second criteria is they have to have the same number of protons. And the final criteria, they need to have different number of neutrons, right? That's an isotope. Part 2. Table 2.1 shows the relative masses and the percentage abundances of the 2 isotopes of boron. Calculate the relative atomic mass of boron to 1 decimal place. So what they're asking you to do here is actually to just find an average, so to say. So in this scenario, we can put it in a situation where we have, for example, instead of seeing this as a percentage, we can see this as having 20 of them has the mass of 10, right? 20 of them has a mass of 10, but the other 80 has a mass of 11. So in this system of 100 isotopes, 20 of them have mass 10 and 80 of them has mass 11. So how do you find the average? You need to take 10 multiplied by 20, right? Plus the 11 multiplied by the 80, right? So this will find the total mass of all of these isotopes, and you need to divide it by the number of isotopes, which is 100, right? So you do the maths, you will actually get 10.8. So the relative atomic mass will be 10.8, Okay, they say ask you put one decimal place, so you put in one decimal place. Okay. Question 3. This question is about ionic and covalent compounds. Sodium reacts with oxygen to form the ionic compound sodium oxide. The electronic configurations of an atom of sodium and an atom of oxygen are shown in figure 3.1. Ions are formed by the transfer of electrons from sodium atoms to oxygen atoms. Complete the dot and cross diagrams to show the electronic configuration of one sodium ion and one oxide ion. Show the charges on the ions. Okay, so you need to first know that they actually want the entire dot and cross diagram. They don't want just the outer shell. So you need to draw everything. Okay, so you know that in an ionic compound of sodium oxide, sodium is the metal, so sodium is actually the one that's going to give their electron to the oxygen atom, right? So it will actually lose one electron. Oops. Let me try and draw this nicer. Okay. So obviously you want to keep the second shell, but you actually lose the third shell because you're giving one electron to the oxide ion, right? So this one, the charge of this will be plus. Okay, so this is one part. And you need to remember to sort of group them into lone pairs. Okay, next, the oxide ion. So this, let me draw another circle. You would draw you would draw something like that. Okay, so the 2x represents the electrons from the sodium ion, which you give to the oxide ion. So since you have 2 of this to complete the outer shell, you have 2 x electrons from the to complete the outer shell. The charge will ultimately be 2 minus. Okay, so basically, the sodium ion gives electron to the oxide ion. The oxide ion will take it and it will complete its outer shell. So both of them are now happy with completed outer shells. So they ask you to write the formula of sodium oxide. So since one sodium ion can only give one electron and the oxide ion needs 2 electrons, you actually need 2 sodium ions per oxide ion. So the formula will be Na2O. Next, carbon dioxide is a covalent compound. Complete the dot and cross diagram. Show the outer shell electrons only. Okay, so if you actually just draw out how carbon dioxide looks like, it will kind of look like this. So you see there's 2 double bonds, right? That means you'll have 2 pairs of this sort of XO combination. You have two of these, right? So in the overlap is where you show the bonds. So you need to draw two XOs in each one, right? And as you can see, the carbon already has a full outer shell of 8 electrons, so you don't need to do anything with this. Next, you just need to fill in the rest with the oxygens with lone pairs, right? So if you can see here, there's already 4 electrons here, so you just need to draw 2 lone pairs, something like that, and this should be correct. You can also replace these lone pairs with X and it'll still be correct. Okay, you can choose if you want to use the dot or the X. Next. The melting points of sodium oxide and carbon dioxide are shown in table 3.1. Explain in terms of bonding why sodium oxide has high melting point. So first off, the difference between sodium oxide and carbon dioxide is one is ionic, right? Sodium oxide is ionic. So what you have to say is in sodium oxide there are positive and negative ions, right? That's the first point you have to say to get 1 mark. The second point you have to say is that they are these ions are attracted to each other by strong electrostatic forces of attraction, right? Strong electrostatic forces of attraction. Because one is positive, one is negative. Obviously, the positive will be attracted to the negative and vice versa, right? So you need to state these 2 points to get 2 marks. And next, carbon dioxide has a low melting point. State the general term for the weak forces that causes carbon dioxide to have a low melting point. Should be pretty simple. Is intermolecular forces. Okay. Intermolecular means between molecules. And melting point is determined by the forces between molecules, not within the molecule. Okay, question 4. Oxygen is produced by decomposition of aqueous hydrogen peroxide. Manganese 4 oxide is a catalyst for the reaction. State the meaning of the term catalyst. So, a catalyst is a substance that increases rate of reaction. So this is your first mark. By reducing activation energy and is unchanged at the end of the reaction. Right. So your first mark will be, so this is your second mark. First mark is substance that increase rate of reaction, but the second mark is you reduce the activation energy and it's unchanged at the end of the reaction. Okay, so a catalyst will never be used up in the reaction. Okay, so next, a student adds powdered manganese to aqueous hydrogen peroxide in a conical flask. The mass of a conical flask and its contents is measured at regular time intervals. The mass decreases as time increases. State why the mass of the conical flask and its contents decreases as time increases. So in the beginning, they tell you that oxygen is, right here, you see, they tell you oxygen is produced by decomposition of aqueous hydrogen peroxide. So, why the mass of the conical flask decreases as time increases is because oxygen is produced and it escapes from the flask, right? Why does it escape? Because the plug on the conical flask, you see here, is loosely fitting cotton wool plug. It doesn't actually trap any oxygen in the in the system, right? So therefore oxygen will escape and the mass will decrease. The rate of reaction is highest at start of the reaction. It will decrease and eventually become 0. Why was it highest at start of the reaction? It's because obviously you have the highest concentration of hydrogen peroxide. So since this is a decomposition reaction, the rate will be highest at the start because you will have the most hydrogen peroxide present before it decomposes, right? And next, explain why the rate of reaction eventually becomes 0 is because there's no more there's no more hydrogen peroxide because it has all decomposed. Right? So it will decompose until eventually there's no more decomposition because the H2O2 is all used up. You've already used up all the hydrogen peroxide. So therefore there will be no more rate of reaction. Next, the experiment is repeated at increased temperature. All conditions stay the same. Explain in terms of collision theory why rate of reaction is higher at increased temperature. So when your temperature increases, the first thing you want to say is particles have more kinetic energy, right? Because the very definition of temperature is the average kinetic energy of particles, right? So the particles will have more kinetic energy. The second thing you want to say is there will be an increase in the frequency of collisions. So the particles will collide with each other more often. And because they collide with each other more often, there will be a higher proportion of successful collisions that are greater than the activation energy. Okay, so you have to state these 3 points, you get 3 marks. Okay, so first off, since it's higher temperature, they will have more kinetic energy. When they have more energy, they will collide with each other more often. And since they collide with each other more often with more energy, they'll have a higher likelihood of having a successful collision that is greater than the activation energy. Okay? Next, the equation for decomposition of H2O2 is shown. 50 cm cube of 0.2 mole per dm cube is used. Calculate the mass of O2 that forms using the following steps. Right, so this is pretty simple. They tell you what you're supposed to do already. So first step, calculate the number of moles of H2O2 used. So remember, the formula is mass equals mole times mR. So this is the formula you want to use, right? So to calculate moles, you have to take the mass and you divide it by the mR, right? So in this situation, you cannot use this formula because they give you volume and concentration, right? So you have to use a different formula. The formula is concentration equals mole over volume. So you want to find mole, so you use N equals C times V, right? So the moles would be 0.2, right? This is the concentration. Obviously, you should write the unit times by 50, but you need to divide by 1000 because this is in cm cube, right? You want it to be the same unit at the bottom so that you can multiply it easily. So to convert 50 cm cube to dm cube, you divide by 1000. So you do the maths, you will get answer of 0.01 mole, right? So remember, mole is just a sort of unit. A mole is like a number, right? It's like pi. So you have 0.01 moles of H2O2. Next, determine the number of moles of O2 produced. So to determine the number of moles, you need to look at the equation, right? Since you have 0.01 moles of H2O2, and there's 2 units of H2O2 for every 1 unit of oxygen, you actually need to divide 0.01 by 2 to have 0.005 mole of O2. So you need to look at it in terms of a ratio, right? 2 H2O2 will give you 1 oxygen. So therefore, 0.01 H2O2 will give you 0.005 oxygen. Okay, so answer is 0.005. And finally, calculate the mass of O2 produced. So to find the mass of O2, you're just gonna take the mole you found here, and following this formula up here we have written down, you're gonna take 0.005 times the MR is 32. You get, let's see, put it into your calculator. Times 32, you get 0.16, which is your answer, 16 grams. State the effect on the mass of oxygen produced if the mass of powdered manganese oxide catalyst is increased. So the effect will actually be no effect. Why? Because remember, manganese oxide is a catalyst. It does not affect the reaction other than the rate. This is the only thing that it will affect, right? It will not affect the volume or the mass of the oxygen that will be produced because it's not part of the reaction. It's only there to increase the speed of the reaction, right? So therefore, it will have no effect. Oxygen can also be produced by a decomposition of mercury oxide. The only products of this decomposition are mercury and oxygen. Write a simple equation for this decomposition, right? So, in your reactants, you're going to have HGO, and you're going to decompose this into mercury and oxygen. Remember, oxygen is diatomic, so that's going to be O2. So since you have 2 on this side, you're going to need 2 mercury oxide on the left, and you balance this, you're going to have 2 mercury here. So all in all, it will be balanced. And this is the answer. Next. This question is for electricity and chemical reactions. Hydrolysis of concentrated aqueous potassium bromide using graphite electrons forms hydrogen at cathode, bromine at the anode. Electrolyte becomes aqueous potassium hydroxide. State what is meant by term electrolysis. Okay, so electrolysis is the breakdown of molten or aqueous ionic compounds using electricity. So there's 3 important parts in this. First off is breaking down, right? This is the first important part. The second one is using molten or aqueous ionic compounds. And finally, you need to say that is using electricity, right? Next, state why graphite is suitable use as an electrode. So if you look at this, the system they've got here, they are electrolyzing aqueous potassium bromide. So why do they use graphite? Is because number 1, graphite is conductive, right? It needs to conduct electricity for electrolysis to work. Second thing, it is unreactive, or you can say it's inert, right? It won't react with any of the substances in the solution or the electrolyte, right? Next, write an ionic half equation for the formation of hydrogen at the cathode. So they want formation of hydrogen, so you're going to have your hydrogen ions on the left. You're going to give it electrons, and it's going to form the hydrogen diatom. Okay. Name the type of particle responsible for the transfer of charge in the conducting wires. So this one should be pretty simple. There's only one particle that can do this. It's the electrons, right? In the wires, there can only be electrons. Next, name the type of particle responsible for the transfer of charge in aqueous potassium bromide. So this would actually be the ions, right? In the solution or in the electrolyte, it will be due to the ions, not the electrons. The electrons are in the wires. In the electrolyte, it will be the ions. Next, state the names of the products formed when the electricity is passed through dilute aqueous potassium bromide. So the difference is they're using dilute solution now. So with dilute solution, this bromine will be formed less. So there'll be less bromine since there is more water, right? So actually, it's more about electrolyzing the water at this point. So what will be produced instead? It would be at the anode, which is positive, I have oxygen, right? And at the cathode, you're gonna have hydrogen. Okay. Yeah. This is that's that. Okay, so B, bauxite is an ore containing aluminium. Aluminium is extracted by electrolysis of purified bauxite in molten cryolite using carbon electrodes. Name the aluminium compound in purified bauxite. So, in purified bauxite, the compound will be aluminium oxide. So I just gotta remember Al2O3. Okay. State 2 reasons why cryolite is used in this electrolysis. Cryolite, the main purpose of cryolite actually is to reduce or lower the operating temperature because it's cheaper, right? You want to use cryolite to make sure that your electrolysis can happen in a lower temperature, so therefore it will be cheaper and a lot easier to do. And secondly, you can say that it will increase conductivity. You can also say that cryolite is it will act as a solvent. So you can write three things, but the most important one is this one. This is the most important one. Okay, reduce lower operating temperature. Next, the anode is made from carbon. Explain why the carbon anode has to be replaced regularly, right? So since they are using high temperatures and they will, when you electrolyze cryolite, you will actually get oxygen at the anode, right? At the carbon anode, oxygen will be formed. So since oxygen is formed, the carbon will react with the oxygen to form carbon dioxide. So since the anode will actually react with one of the products and form carbon dioxide, eventually the anode will be smaller and smaller and smaller until it actually eventually disappears, right? Next, hydrogen oxygen fuel cells can be used to produce electricity in vehicles. Write the simple equation for the overall reaction in a hydrogen oxygen fuel cell. So this is pretty simple. It will just be the combustion of hydrogen. So H2 plus O2, you get 2H2O. And you balance. So you'll be, done. Balance. Okay. State one advantage of using hydrogen oxygen fuel cells instead of petrol. So petrol will release CO2, right? I would say the biggest advantage is probably that water instead is released instead of CO2. So you can say no CO2 release or evolve. Nice. Great. Question 6. This question is about sulfur and compounds of sulfur. Sulfur is converted into sulfuric acid by the contact process. Okay, this process involves 4 stages. Molten sulfur is converted to sulfur dioxide. Sulfur dioxide reacts with oxygen to form sulfur trioxide. Sulfur trioxide combines with concentrated H2SO4 to form oleum. Oleum reacts to form concentrated sulfuric acid again. Okay, in stage 1, iron pyrites can be used instead of molten sulfur. They are heated strongly in air. Balance the equation. Okay, so this one is simple balancing. So where I will start with this is actually on the reactant side. So as we can see here, this oxygen, we know that oxygen exists in a diatomic form, right? It'll be O2, right? Here's O2. So since this is the only, on the left side, there's only one thing that can provide the oxygen, which is the O2. It means that this compound must be present in even numbers, right? Because this here, there's a 3, oxygen 3 here. So to make the right side even, this compound must be in like an even number. So let's try 2, right? So 2. So we can start off by balancing the iron, right? 2Fe2, there will be 4 iron here. And 4 times 2, we can do sulfur, right? So 4 times 2 will be 8. So you're right, 8 here. And finally, we can total up all the oxygen. So 2 times 3 is 6. And then 8 times 2 is 16. So 6 plus 16 is 22. And 22 divided by 2 will be 11. Right? So very simply, you start off with I started off with this one. And since this is a 3 at here, you know that this compound must be present in even numbers. And then from then on, I can slowly sort of branch off and find the balancing for all of this. Okay. Name Fe2O3, include the oxidation number of the iron. So obviously, it's pretty simple to tell that this is iron oxide, right? But since they want oxidation number, how do you know what iron this is? So oxygen has a charge of 2 minus, or oxidation number of 2 minus, right? So since this is a compound and it is neutral at the end, so that means 3 times 2 minus plus 2 times something, right? We'll call it A, equals 0. So therefore your iron, your A, -6 plus 2A equals 0. Your A has to equal 3, right? So therefore the oxidation number will be 3. Done. Next, the equation for stage 2 is shown. The fall reaction is exothermic. The reaction is carried out at temperature of 450 and pressure of 280 atm. So this is actually the main point, the most important part of the contact process, right? So using explanations that do not involve cost, so you cannot talk about cost here. Explain why temperature is greater than 450 degrees is not used. So with this, you need to think about this guy's principle, right? He tells that in an equilibrium, the reaction, or the equilibrium will favor the opposing change in the system. So for example, in this case, why a temperature greater than 450 degrees is not used is because the forward reaction is exothermic. So if you increase the temperature, it's gonna favor the reverse reaction, right? Because endothermic will decrease the temperature of the reaction, exothermic will increase the temperature. So if you increase the temperature, it will favor this side, the left side. So it's not used because you have a lower yield of SO3, which is what you want on the right side, right? Explain why a pressure of lower than 2 is not used. This one has to do with rate. Is too low. Okay. Next, when sulfuric acid reacts with ammonia, the salt produced is ammonium sulfate. Write the simple equation for this reaction. Okay, so first ammonia react with sulfuric acid. You get ammonium sulfate, right? Sulfur, the sulfate ion has a 2 minus charge. Ammonium has a +1, so you need 2 molecules of ammonium with 1 molecule of sulfate ion, right? So to balance, you need to have 2 of these, and that's it, right? Next, lead 2 sulfate is an insoluble salt. It can be made from aqueous ammonium sulfate using a precipitation reaction. Name a solution that can be added to produce a precipitate of lead sulfate. So you need 2 criteria here. Number 1, the compound must contain lead 2, right? That's the first thing you need. The second thing, it must be soluble as well. Okay, you want to react it with its aqueous ammonium sulfate. The only thing that has these 2 properties, it's pretty simple, is lead 2 nitrate. Right? Why do you want it to be soluble? Because they want a solution, right? And you're finding a precipitate, so you want a soluble compound. Okay. Next, write an ionic equation for this precipitation reaction. Include the state symbols. So they want you to formation of lead sulfate. So it'll be Pb 2 plus Aq, since they want state symbols, right? It's in a solution. Add SO4 2 minus, also Aq. You form PbSO4, but this will be solid. This is a precipitate. Okay. The precipitate of lead 2 sulfate forms in an aqueous solution. Describe how pure lead can be obtained from the mixture. So, what's gonna happen is when you react the 2 solutions together, you get like the solution, and you'll get the lead sulfate sort of sitting at the bottom, right? So how you want to remove this? First, you need to filter, right? You need to filter off the solid. So next, what you're going to do with the solid is you're going to rinse it with distilled water, right? To get off any excess solution that's still clinging onto the solid particles. And finally, you need to dry. Yeah, you can use several methods to dry. You can use like a paper towel, or you can use like an oven or hair dryer. Anything that gives heat and will eventually dry out the lead sulfate will work. Okay. Next. Questions about organic compounds. Butane reacts with chlorine in a photochemical reaction. State the meaning of the term photochemical. Photochemical simply means involves UV light. Okay. Next. An organic compound with the formula this is formed when 1 molecule of butane reacts with 1 molecule of chlorine. Draw the displayed formula of 2 possible structural isomers with the formula formed in this reaction. So structural isomers means they have the same molecular formula. They're just positioned differently, right? So how it's going to be is, since it's butane is an alkane, you're going to basically draw in a straight line. So how I would do it is, first I'll draw this, right? So this is one possible structural isomer. The second one, I'll probably just move the chlorine to somewhere else, right? Over here. Okay. So very simply, you just need to move the the chlorine to a different place. You can't you can't draw something like you can't move it here, for example. You can't move it on the left side because actually these two, this one and this one, are the same thing. It's just they are flipped around, right? So you need to be careful. In fact, I think these two are the only acceptable answers, I think. Okay. Next, the structure of compound A is shown. Deduce the molecular formula of compound A. So molecular formula, you just need to count the number of everything, right? So we'll start off with carbon, C4, it's 4 carbon, right? 1, 2, 3, 4. Next, hydrogen, 1, 2, 3, 4, 5, 6. H6. And finally, how many oxygens are there? There's 3. C4H6O3, that's your answer. There are 3 functional groups in compound A. Name the homologous series of compounds that contain the following functional groups. C double bond C will be an alkene, right? OH is an alcohol. COOH is a carboxylic acid. So this one is just testing your knowledge on the functional groups. Okay. Next, state what is observed when compound A is added to aqueous bromine. So this one is actually testing for this one, alkene. It's testing for alkene, right? So since there is an alkene group, it will decolorize the water. Or you can just say it'll turn colorless. Right? Aqueous sodium carbonate. So this one is to test for acid, right? So since it's a carbonate, it will react with the acid and it will fizz. Or it will bubble. Right? So that's what you will see. What is observed, it will fizz bubbling. Okay? Next. Compound A can be used as a single monomer to produce 2 different polymers. Draw 1 repeat unit of the addition polymer. So, remember, in an addition polymer, the important part is actually the CC double bond. What you want to do is you're going to actually break this into single bond, right? You're going to draw something like that. So to draw 1 repeat unit, you just need to draw exactly the same thing you see here, but you just need to break the double bond to a single bond and extend it out to the sides. So how it's going to look, it should look something like right. Something important to note is you need to make sure that the bonds is actually going to the correct element you want it to go, right? So in this case, I drew it a bit poorly here, but you want to make sure that the bond is going into the carbon, not the oxygen, okay? Even though it may look correct, it's not correct because they will think that you're saying that the bond actually goes to the oxygen when in fact it does go to the carbon instead. So you need to be careful where you put the bond, where you point it to. And you just extend out the lines like that. So since they want 1 repeat unit, this will be your answer. 2 marks. Sorry, you'll look something like this. Next, compound A can be converted into a dicarboxylic acid. Name the type of condensation polymer formed from a dicarboxylic acid and a diol. So this will simply be a polyester. Right, so when you react carboxylic acid with alcohol, you will get an ester. Since it's di and di, and you have a condensation polymer, it will be a polyester. And oh, that's it. Right, so that's it for this video. See you next time.